All right, kids. Let's work through example 1.17, finding the area between two polar curves using the GeoGebra CAS. So I've already put a lot of stuff in. So I've graphed the two functions that they gave us, created my slider so we can kind of see how the points are moving and what's happening. It appears that the limits of integration go from probably there, which I bet is like 30 degrees or pi over 6, and it goes all the way over to here, which my guess is 150 degrees or 5 pi over 6. But we can find this out exactly. So this is a computer algebra system, so I could solve 6 cosine of t equals, then I'll go 2 plus 2. Oh, that's not a cosine. That should be a sine, shouldn't it? And this is going to be 2 sine of t. And I probably should declare my variable as a t. And so don't freak out about this as solution set. There are two solutions. K is an arbitrary integer. So if one solution is pi over 6, I could add 2 pi to that or subtract 2 pi from it, and I would get another solution. So from pi over 6 to 5 pi over 6 appears to be what my limits of integration are. And so let's do an integral. So when I type in integral, there's this magic integral between. So let's see what this does. So, takes the function, my guess is the outer function, which would be the 6 sine of t, and the next function would be the inside function, which would be the 2 plus 2 sine of t. I'm going to declare a variable, so I'm going to use this function here, start value and end value. So let's try this out, see what it does. So it is 6 sine of t, and then it is 2 plus 2 sine of t. The variable is t. The start value is pi over 6, and the end value is 5 pi over 6. And let's see what our answer is. Let's see if it's close. And so I've got it looks like I have the 4 pi part, but mine's a negative 4 pi, but I know what I did wrong, and you might make the same mistake, as I forgot to square my functions, because really it's the area between the square of those functions. So let's go back here, and let's click on that and put a parenthesis around that puppy and square it. And let's do the same thing here. Let's put a square around that one, and then 8 pi. But again, the answer is 4 pi. So what am I missing? I'm missing these 1/2 that are up here, because really I need to take half of each of those integrals. So I'm going to go up here, and if I take half, it's 4 pi, so I'm good. You should try to do this same thing again using two distinct integrals and seeing that the difference between them will give you 4 pi. But again, it's not my intent to have you all fumble through a bunch of different integrals to get to an answer. Use these tools, which are probably some of the same tools you'll be using once you get past your freshman year in college.